To have something like this that's an autonomous drone doing missions be used at scale for this sort of large critical infrastructure inspection, it has to be about as reliable as, somebody installing a printer, copier, or buying a pickup truck or a washing machine. Like, it just has to do the job. The drone can know where it is without GPS. The drone can navigate and manage a bunch of complex planning objectives at a low level to manage aerodynamics and camera motion and drone motion and high level tasks of different kinds. For a bunch of reasons, basically, I'm against weaponized autonomous systems. We will not weaponize our drones. And for a bunch of reasons, like we're focused on the camera and the reconnaissance as the core focus of our products there.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Labenz, joined by my co-host, Eric Torenberg. Hello, and welcome back to the Cognitive Revolution. Today, July 4th, is Independence Day in the United States. So while it wasn't exactly planned this way, it is, I think, somehow fitting that we share this interview with Hayk Martiros, Vice President of Autonomy at Skydio, the United States' largest commercial drone maker. There is a lot to say about drones. This industry sits at the intersection of so many critical topics. Automation in the future of work, the relationship between the technology industry and the government, the war in Ukraine, the trend toward autonomous lethality, which, to be clear, Skydio has committed not to produce, the US-China rivalry across all sectors, the prospect for far safer infrastructure and life overall, but also the possibility and the threat of mass surveillance. I attempted to cover just about all of this with Hayk and found him to be a sophisticated thinker across the board. For starters, because it was a relative blind spot for me coming in, and I suspect it is also for many of you listening, I really dug in deep on the autonomy systems that Skydio has developed over the last decade with traditional software. Long story short, they have built an impressive vertically integrated stack that translates the combination of 360-degree video inputs and also user instructions to specific detailed flight paths, 3D spatial models, and other visual reconnaissance, largely running everything on the device so that the drone, as they say, is easy to fly and hard to crash. This approach, of course, also has opened up a 10 times bigger market for Skydio than existed before because it no longer requires a skilled pilot to operate. I was really fascinated by all of this. But we did eventually get around to what Hayk and team are working on now, which is the addition of a higher level, more semantic AI layer that can now be placed on top of all the more optimized, explicit technology that they've already built and deployed. This layer promises to eliminate the need for operators pretty much entirely in many contexts, as customers will be able to give verbal and other high-level direction to remote systems. They've actually recently introduced a dock that you can install really anywhere, say on an oil rig or the middle of a dam somewhere in some remote place, and still carry out detailed inspections and other operations remotely. This combination of existing hard technology and the new natural language or other high-level user experience strikes me as an extremely powerful one that we're likely to see play out across lots of spaces. And in fact, this is a big reason that I expect today's existing winners to be the ones that benefit most from the AI technology wave. No surprise then that Skydio, which has every branch of the US military as customers, just raised another $230 million to expand its factories. At the end of this conversation, we talked about how Skydio drones, which are just a couple of pounds and really not capable of carrying more than a small additional weight, in which again, Skydio has pledged not to weaponize, are nevertheless being used in military contexts, including in the Russia-Ukraine war. We also touched on the less followed conflict currently affecting Hayk's home country of Armenia and neighboring Azerbaijan as well. It is a sad reality, especially considering the urgency of global problems such as avoiding an AI arms race, that there's still so much conflict in the world. But in the context of the Russia-Ukraine war and ongoing US-China decoupling, it is hard to deny that the United States and the West more broadly need champion companies to lead critical industries. To my eye, Skydio looks to be extremely well positioned to play that role in the vertical of autonomous inspection and reconnaissance drones. All this brings me to a couple thoughts about the United States in the context of the cognitive revolution. It's commonly said that the United States' greatest advantage is its ability to attract talented immigrants from around the world and to reinvent itself on an ongoing basis. And boy, has that been evident across our guests to date. I've always just followed my interest in specific research and projects and products to identify guests to invite for the show. And I've never really worried about the resulting demographic mix. But looking back, it is incredible how many of our guests grew up somewhere else around the world and are now living and working in the United States, particularly the entrepreneurs and the researchers. Amjad of Replit from Jordan, Eugenia of Replica from Russia, Anton from Chroma from really all over the world, Flo from Lindy is from France, Mahmoud Felfel from PlayHT from Egypt, Arvind Srinivas from Perplexity, Kirthana from Google Robotics, Shreya Rajpal of Guardrails, and Vivek Natarajan of Google MedPalm, all originally from India. Andreas Stuhlmuller of Aut and Elicit from Germany, Ronen Eldon and Yuanju Li of Microsoft Research from Israel and China, respectively. Last week's guests, Jiming Liu from MIT and Lily Yu from Meta AI, both from China. And finally today, Hayk from Armenia. That's nearly half of our episodes, all living and working in the United States today. Personally, I hope that the United States can maintain its open posture and welcoming culture and extend this advantage going forward, both because I just like to see people have the opportunity to chase their American dreams, and because I think the world really does need a deeply connected, multicultural, intellectual hub. And right now, the United States is the best candidate that we've got. At the same time, I also feel like we should broaden the reach of the show by connecting with more guests working in AI outside of the United States. So, if you have any suggestions for entrepreneurs or researchers working on AI internationally that you believe would make great guests for the cognitive revolution, please do let us know. You can email us at tcr@turpentine.co or send me a direct message on Twitter where I am at Labenz. Without any further ado, I hope you enjoy this July 4th conversation with Hayk Martiros, VP of Autonomy at Skydio. Hayk Martiros, welcome to the Cognitive Revolution.
Thanks, Nathan. Yeah, I've been checking out some of the other episodes, and I'm a fan.
Thank you very much. That's kind. Well, I've also been checking out a lot of the work that you've been doing over the past better part of a decade, and really excited to have this conversation and dive into everything that goes into making an autonomous drone like the ones that you are building at Skydio. So maybe just for a little bit of background, tell us a little bit about yourself. And you're clearly a multi-talented individual. It's sort of an odd facet of the AI moment right now that you've had this project in process for a decade and built a multi-billion-dollar unicorn business. And I would bet that most of our listeners, if they know anything you've done, would know your Refusion project from not too long ago, where you created a variation of stable diffusion that would create spectrograms that could then be turned into music. So that's not going to be our focus today, but that was cool. And it's also kind of a window, I think, into who you are as somebody who clearly, has their hands in a lot of different areas of technology.
Yeah, cheers. I'll try not to pivot to talking about that for the whole hour. So about my background, I mean, I think it's kind of an odd one. So I was born in Armenia just after the collapse of the Soviet Union. And then when I was 7 years old, my family moved to Alaska, kind of a middle of nowhere in Fairbanks, Alaska. My dad got a chance to study earthquakes there as a seismologist. And then I grew up there for about 10 or 11 years, moved to New Jersey, ended up going to Princeton for my undergraduate, and kind of started out very much as a mechanical engineer there. I considered being kind of a music major or architecture, but quickly got into just working on software. I kind of became the robot software guy, and was really interested in that, and came out to Stanford for the master's after that. And as I was leaving that, just thinking about what I wanted to do, kind of definitely in robotics. And I was, like most Stanford students, thought I was some kind of embodiment of Elon Musk and Steve Jobs. and was thinking about, should I start a company? What should I join? And at that time, Google X had acquired basically every interesting robotics startup around 2015. And I was kind of looking around, trying to get into that, think about what to do. And I managed to meet Adam, the CEO of Skydio. And I didn't know anything about Skydio. I thought it was already a big company. I found him on Angel List. And he started asking me some math questions on Skype. And I was pretty into it. So then I went to meet them at their office. But the office turned out to just be a house in Atherton, and where the three of them were working out of, the three founders. And it was pretty incredible. Like they had started the Google Wing project at Google X with their advisor from MIT. And then they left after about a year because they were just tired of feeling like it was a side project of a company that was focused on, online ads and search, and wanted it to be a core thing. Like if you're building robots, it has to be a core thing. It's really hard. And so I was, pretty inspired by that and excited to take a risk. And I've been there for, just over 8 years now, basically my whole career outside of school.
And so you guys have built a lot coming out of that house in the last 8 years. I don't know to what degree people will be familiar with Skydio and the product. So I thought, for starters, we could just kind of take a quick rundown of like what it is. I, after marching my way through all of the marketing materials and demo videos on the website and all that stuff, kind of came away with the takeaway that it's like the most advanced eyes in the sky that are out there today, in the sense that it's super easy to fly. Anyone can fly is one of your big value props. And then it's really just like all eyes, it's a light, seemingly pretty agile device that has 6 4K cameras on it. So again, really emphasizing like the collection of visual data, seemingly a lot of onboard processing to make use of all that. And then, I think there's really interesting trade-offs that I'm interested to hear more about around like how big to make it and, the power that you can bring and how the power itself, weighs you down. So if I read the latest spec right, it's a half hour essentially flight time and a 6 kilometer radius that just goes and looks at stuff. So tell me what would you how would you complicate my kind of takeaway or synthesis? That was my GPT 3.5 level summary of the website.
Come on, at least 3.7. It's pretty good. Yeah, I think that was good. I mean, essentially, Skydio is a drone company and an AI company, and we're kind of both horizontal and vertical. So the way we started out was really around just the autonomy software part. We were like, okay, we can make autonomy software so that robots can be intelligent and trustworthy and navigate the world. We realized pretty soon after that to really make an autonomous agent that works well, to have a shot at that, you have to kind of control the whole stack from the mechanical design and the aerospace and the vibrations to the cameras and the drivers and the chips involved and the software that runs it all. And so then we became a hardware company. And for the first several years of the company, we were a consumer hardware company, which is a notoriously difficult and bad idea for a startup. There aren't that many examples of successes there. But we essentially were focused on a drone that is intelligent enough to avoid obstacles, not crash, navigate without GPS, and capture cinematic kind of Hollywood style footage of somebody that's skiing or mountain biking or doing some kind of action sports. And that is something that, a lot of people have thought about. There's ideas, but the execution or realization of that is really difficult. So that was kind of the journey. And we have, a lot of tens of thousands of customers that use that and are excited by that. But now Skydio is a much broader company. We're the biggest US drone maker. And our focus is really around everything that is possible with autonomy to unlock more intelligent drone behavior so that people that aren't trained experts can use the drone, so that people who don't know anything about flying robots can essentially just use the data captured by the robots and all the workflows around that. And so part of that path is the design of the hardware and the aerospace components and software and everything. And part of that is just like working into these product use cases and really thinking end to end in that nature.
Hey, we'll continue our interview in a moment after a word from our sponsors. Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
So at this point, Skydio has a ton of business around inspection and mapping and situational awareness for fire and police and defense and all types of kind of physical infrastructure inspection. So we do a lot, and there's a lot of surface area. So in some ways, it's kind of the horizontal play of this robot that captures image data that can go anywhere. And then in some ways, it's more of like an end-to-end, like solving real problems, making things a lot safer and cheaper than alternatives in industry use cases. I think that's where we're at right now, and we're still. I think Skydio is very much kind of a generational company where we should be a tens of billions of dollar company in maturity, and still just a tiny fraction of the use cases and the maturity of where we need to be. And there's just a lot to build, and that's both kind of an opportunity and the core kind of challenge of the company, I would say.
It definitely seems like a market that's going to continue to grow for the foreseeable future, and probably pretty quickly, given all the kind of trends that are converging to make this, better, faster, easier, cheaper. It seems like, the sky is the limit, no pun intended. So as the business has evolved, you kind of mentioned the main use cases. I would guess that like the sort of commercial industrial inspection would be the biggest segment, because it just seems like there's a practically infinite amount of that out there. And if I'm somebody that has, a lot of cell phone towers to inspect, or like, oil rigs or whatever, I'm like, what sounds a lot nicer than having somebody climb this pole is like using this drone, right? So that seems like if you can get the product to work well enough, that it would be a relatively easy sale and like a huge market. Is that the kind of core, driver of the business today?
Yeah, I would say that's the biggest part of the vision. If I had to pick a single part, for sure, just that the world is just covered in infrastructure that makes society run, from electrical equipment to roads and highways and bridges and dams to all sorts of buildings and indoor industrial facilities and all. Just like every Fortune 500 company has a huge amount of these assets. Every country has a huge amount of these assets. So I think practically infinite's a pretty good analogy for that. Like I was just traveling through Armenia, where I was born last week, and noting just how every corner of the country is still just covered in transmission towers, just like everywhere else on Earth. So I think, yeah, absolutely, the small drones can do it, way faster, way cheaper, and way safer, and that's a huge part of the opportunity. But also, these are some of the kind of most critical, important, and slow moving kind of industries. And so to handle really getting into a market like that, like inspection of utility equipment, it takes years and years to really get to the point where you're taking, here's here's probably what the cutest drone that we have is. There's a couple different ones that have different kind of hardware specs, but to have something like this that's an autonomous drone doing missions be used at scale for this sort of large critical infrastructure inspection, it has to be about as reliable as somebody installing a printer, copier, or buying a pickup truck or a washing machine. Like it just has to do the job and be reliable. And the entire set of things of being a trained drone pilot with a yellow vest and a hard hat that's flying the thing has to go away, and the entire like craziness of this thing is navigating by itself and doing all this stuff. Like we have to get past that and cross the chasm to the point where it is like the standard tool, and that's something that takes a tremendous amount of engineering and product and sales effort. And so I think that's kind of the path we're on. And there's a whole nother kind of half of the focus, which is around situational awareness and security. And those use cases there's a lot of overlap, but there's also good amount of differences on all fronts.
So that's great context. Let's talk about how you did it. Because it does seem like you have crossed that chasm, and to a very significant degree, like these things are deployed in the field doing the job. Recent news item about the company was, I believe, it was a $230 million raise to expand the factory. And I'm sure there'll be some other uses of proceeds as well, but it's always good when the factory, becomes the bottleneck in a in a company. So maybe just let's dive into the approach that you guys have taken to AI. It's interesting. You've been doing this kind of in a very parallel world, I would say, compared to like the LLM, track that is currently getting the most attention. But probably a lot of the same, principles can apply. For one that I always like to use is like, what are the inputs and what are the outputs of this system? You held up the drone a second ago, and I was kind of thinking like, okay, if there's an AI system, that I could draw a box around here, it's probably starting off with the 6 raw video streams that are coming in from the cameras, and it's then ultimately outputting. My best guess was 4, the kind of speeds for the blade at any given time. And I realized I don't know if there's maybe more variables that it needs to predict or control, or if those are, if the 4 rotors are kind of the only thing. But just for starters, yeah, to help us understand kind of what the inputs are and broadly speaking, how those are transformed into the outputs.
Yeah, for sure. So, and I think you said it pretty well. So, on this particular drone, there's 6 of these navigation cameras. Each of them has a 200-degree field of view. So you kind of get the 3 that see the entire upper hemisphere all together, and then there's 3 on the bottom that see the bottom hemisphere all together. So the drone is kind of built. Our first drone had 13 cameras, but it's the same concept. It's just to see in every direction with multiple cameras at once, and that's the core and primary input. And there's other sensors like a GPU, accelerometer, gyroscope, things like that have important use cases. The vast majority of the information is from the cameras. And when Skydio began, it was definitely it was pre deep learning as something that was really worked well in computer vision and possible to run on the edge, especially. And so it was a whole different story from where we are today. But there's also other sensor possibilities, like the most common one is LiDAR, and you see this debate, rage on in the self-driving community. But specifically for these small, lightweight drones, the size and the cost and the power usage is completely critical. And cameras being on the train of cell phones with the scale in billions, investment in tens or hundreds of billions are getting so small and so cheap and so high quality that that's really the path that we've followed with our drones and compute stack in general. So that's the primary input, and the output, in this case, is being a quadcopter has 4 rotor blades. The most low-level input we deal with is really at the level of the kind of voltages that are commanded to the actually wound up kind of magnets along the radius of each of the motors, right? And that kind of thing happens at something like 30 kilohertz. And so it's very, very low level when you get all the way down. And we do control that whole stack. And that's one of the interesting questions of it's a long way to traverse from very high level decisions that happen at low on a few times a second or something to the most low level thing that happens at many orders of magnitude faster. And so that's kind of the overall system, and the way that's broken into, approaches and components is important. It's something that we've tried to be very, very thoughtful about.
Yeah. So tell me maybe more about that. I mean, the 30 kilohertz, does that mean you're actually making updates to the voltage 30,000 times a second?
Yeah. So the most inner loop there is basically the current controller for the motors. And that's something like, it's on a chip that has something like 200 instructions to spare every one of those loops. And so that's something that's very far from a large language model or something like that. Yeah, again, as much as the entire stack can be thought about and designed together, the more chance you have of making a robust autonomous robot.
Yeah, it's interesting. The end-to-end concept always, comes up in AI in a lot of different contexts, and this is kind of coming up in a bit of a different way because you're not training an end-to-end system, but you are controlling all the components and kind of designing them to work well together. Could you maybe kind of just outline how many layers of, I guess, abstraction and kind of communication there are between, those raw inputs of the cameras plus the other sensors, and then all the way down to that lowest level. And I'd also be really interested to know where, if anywhere, there are true kind of black box models, where something is, kind of the product of gradient descent in such a way where, you haven't specifically controlled, all of the translation from the input to the output of that layer.
Using a metaphor from kind of like classical control theory, I would say that every time you have an order of magnitude change in the rate at which you need to do things, it often makes sense to kind of have a different system. And the theory there says that, like, let's say you're operating something at 10 hertz, you're making a decision 10 times a second, but there's an inner loop that's making a decision at 100 times a second, then you probably don't need the outer loop to care about the inner loop as much. The dynamics can be kind of abstracted away. So at that level, kind of, if you think about something at the lowest level happening at tens of thousands of times per second, then the highest level is maybe once a second. Then you have something like 4 layers in the loop there, and I think that's a pretty close match to what a one sentence idea of the how the Skydio system is built would look like. And so in terms of there's a lot of advantages to kind of end-to-end reasoning, because you get to just kind of jointly take the information, you get to learn from it, from data. You don't have to figure out how to program these things with complex multimodal inputs. And there's obviously just tremendous advantages to that. It is hard to cross those gaps of different orders of magnitude of frequencies with that. And I don't think it makes a ton of sense to do that. On the drone, there's something like 10 over 10 different deep networks that are running for different purposes. Probably one of the most interesting ones that's the core of, among the things we've put the most work into, is the obstacle avoidance system. So we were the first company to ship a deep learning based obstacle avoidance system. And we published a paper on this in 2017 and shipped it on the Skydio 2 for the first time. And that just had tremendous wins over the systems before it that were more kind of classically algorithms that we wrote. And the capability there is to, for things that are in camera images, what's hard is that you don't see a lot of the easy stuff is easy. You master that quickly. But then the difficult cases, the signal is not there in the pixels as much. And I'll give you an example. Like, let's say you're in a facility that has a white ceiling that's really textureless. And you have a camera that's looking upward and it's basically all white. You might also have a day that's just kind of a foggy day where the sky is all of that same color. And you really need the context of all the surrounding cameras and imagery to know that that is the sky and you can fly there, versus that's a ceiling and you're going to crash into it. And so the same thing could be said for different types of sun glare, really difficult thin branches with a backlit sun, all sorts of challenging cases. And so deep learning is just incredible at adapting to those use cases. And I think where you draw the boundaries often also depends on what your inputs are, not just how fast you're running it, but which cameras, which resolutions, what type of pre-processing is important. And I think more and more so at the high level of the stuff that can run at lower frame rates and is reasoning, there's a huge opportunity for end-to-end reasoning, particularly just what you might call embodied AI, where the drone, you have models that understand camera imagery, understand some kind of high-level task, whether that came through an example or whether it came through an instruction that's written with language, and translate that into kind of the high-level motion of the drone. Our core bet and layers that we build is basically like we build this hardware that has the cameras, it has the chips, it has the drivers and core kind of embedded software to have a reliable platform that works, that flies, that things don't go wrong. And we have the sort of health monitoring, management, and state machines layers that just kind of do the right thing. And then we have the algorithms that make it so the drone doesn't crash. The drone can know where it is without GPS. The drone can navigate and manage a bunch of complex planning objectives at a low level to manage aerodynamics and camera motion and drone motion and high-level tasks of different kinds. So all of that on top is kind of the core autonomy navigation layer that can have basically APIs to it. And on top of that, building a system that is able to basically exhibit embodied AI, where you're able to understand, image data coming in, video data, as well as a high level instruction like, natural language or examples demonstrated by a person, and translate that to the high level commands of the robot. On top of that API is I think the hugely valuable robotics opportunity. Doing that at the same time as controlling the voltages of the motors doesn't make any sense. Doing that at the same time as avoiding obstacles possibly makes sense, but not necessarily. And so I think that's a huge opportunity, and we're going to see a huge amount of this sort of embodied AI in the robotics world this year, as it kind of distills down from what's really come from the computer vision and NLP communities.
Yeah, makes a ton of sense. So I'm kind of just working my way back up the layers as well. So you've got the lowest level stuff of the 30,000 hertz controllers of voltage that ultimately translates into, how fast should the blade spin and how much force is it going to generate. Up a level from that, you've got kind of low level control systems that, I guess I don't know exactly how high you jump there. Like it seems like it's probably 2 levels up to go to something like hover, to just sort of maintain, state. I'm guessing there would be kind of another layer of abstraction between the lowest level and something like, just hold steady. Is that true? What is it? What is kind of in between there?
Yeah, for sure. So the dynamics kind of flow up from, the to the currents of the motors, and then to the sort of desired rotation, kind of angular rates of the motors, which then flow up to kind of the desired angular rates and acceleration of the drone body itself, as it relates from the models of the motors to the body, which then roll up to the desired kind of orientation of the drone, which then roll up to the desired position and velocity of the drone, because of course the quadrotor moves, because all the rotors are mostly in plane, has to tilt to the side to then move sideways. It can't just move sideways in an effective way. And so that then rolls up to, the trajectory of a position of the drone. So there's a few layers there, and we do reason about a lot of those layers together. But basically we have quite a mature system now that we've built using this symbolic computation layer that we've developed and rely on a lot here. But at the end of the day, it's an optimization. It's a nonlinear optimization, and it's not of the sort of gradient descent. It's more of a second order optimization that's being solved. That's using basically a quadratic approximation of a lot of different objectives and the dynamics of the drone to reason together. And at this layer, we do something like 500 iterations per second. And this is thinking about how to balance the rotor aerodynamics with the motion, the orientation of the drone, with things like not crashing into obstacles and the high level desired commands of the user. And those are things that really do make sense to reason together, because as soon as you decouple them, you're going to have issues, because the aerodynamics, you might be having a big gust of wind at the same time as you're trying to fly downhill, and then rotating to avoid a thin power line. And all those things are going to clash with each other, because you'll hit the power limits of your propeller, which then prevent you from tilting, which then leads you to crash into the wire. And so that's the kind of system that, is in that realm of like tens to hundreds of times a second, and is covering a lot of ground in the core navigation of the drone.
So it sounds like there's essentially kind of a almost like a Russian doll kind of nested layers of basically the same setup that people have been, for listeners to the show, probably are most familiar with, like the LLM based agent, where you kind of have a loop, and every time you go through that loop, you get to kind of observe your state and maybe issue a command, kind of the React paradigm for setting up an LLM agent that obviously works at this like very high level natural language. But it's kind of that all the way down, right? Is what I'm taking away from this. There's a sensor that detects acceleration, for example, and it kind of knows what it wants to be detecting. And when it's deviating from that, it knows how to send a command down to a lower level to adjust, so as to hopefully, bring it into detecting what it should be detecting, and that happens, however many times, and at the lower level, it just spins even faster.
Yeah, I think there's a few levels of loops. Each of those loops covers a lot of things and maybe has a few kind of tricky things about it. And one of the things is typically the states you care about are not directly observed. So there's kind of a coupled estimation problem where you're trying to figure out the variables you really care about. For example, what is the angular acceleration of the body of my drone, or what is the position of my drone, or what is the location of the motor right now? Like those are not things you directly measure with a sensor, but you're estimating from other sensors. And at the same time, you're giving commands. And so that sort of joint estimation is a common part of it. And then the second part of it is that you have to reason about a lot of the uncertainties in play, because when you're trying to estimate unobserved quantities, you have to carefully consider what your numerical kind of information or covariances are between your variables and handle those layers.
And so this is maybe a good time to introduce your open source library, SymForce, because I think this, if I understand correctly, is like, this is the framework that you have developed over a number of years to try to make this more manageable, right? The low level number crunching of this sounds extremely tough, especially when you build in all those uncertainties and, kind of having to deal with distributions of possibilities, et cetera, et cetera. SymForce allows you to, again, it kind of bridges a divide, right? On the one hand, you have the human who is trying to figure out how to program the device to deal with this sort of stuff and wants to do it in a more conceptual way, a more maybe, say semantic way. But then that ultimately is going to translate to a lot of like low level number crunching. And that you have kind of no choice but to really optimize in order to get it to work on the device. So this library sort of bridges that gap by presenting to the developer a comparatively high level interface to deal with, and then handles that translation down to the super low level. And if I understand correctly, no black boxes really in that system, right? Like that's all something that's been truly like designed, architected, developed, as a kind of traditional software project, albeit one that ultimately kind of adds up to AI.
Yeah, I think you're right on the dot. So that SymForce is something that lives at the layer below what I would consider sort of the embodied AI, kind of layer where you're making these high level decisions. It's more about the effective execution and numerical, inner loops here. So SymForce is something that kind of arose out of problems that we've been dealing with for many years, and it was definitely my kind of baby and passion project of building this approach. And so at the core, it's a library for symbolic computation, code generation, and nonlinear optimization. So the principles how it works is you as an engineer, as a roboticist, design some kind of symbolic expression. So you're writing, it's kind of like writing a mathematical equation or models of things. So we might say, here's how we think the map model of the propellers or aerodynamics of the drone work. Or it might be, here's how my robot arm moves given commands. And you build expressions for those in kind of a mathematical language. You're not actually having numbers. It's more like you're writing equations. And then you can symbolically manipulate those. Like you can do operations like simplification or taking derivatives or factoring. And you can do all this without worrying about the speed that this runs at. And you can do it from a place of like analysis and understanding. And then from that, basically something you write in Python, which is pretty analogous to how you might write a PyTorch model specification for a deep network. You're writing it in terms of the layers and operations and stuff, but it's really meant for not sort of massively data parallel on every pixel of an image, but more for doing numerical computations that are more with scalars. And so once you have that symbolic expression, we can generate kind of extremely fast runtime code that could be, for example, our core motion planner ends up being 100,000 instructions with no branches in a single function. And that's something that is a huge speed win for our drones and allows us to run very sophisticated algorithms on the edge in a matter of tens of microseconds for a complicated loop like that. And so all of the high level like ability to, as an engineer, develop, iterate quickly, understand what you're writing, and then at the same time generate kind of production ready code that's automatically translated and tested. And so in that way, the code that's output by the code generation is sort of a black box, in that you're not going to look at those 100,000 lines and figure out what's going on. But if you trust the system, then you can understand the symbolic expression that went into that. And then we have a layer of optimization, and you plug in those generated expressions into kind of a sophisticated optimization library that is built to run very fast on board the robots. And that supports essentially a lot of the tasks we do, from the sort of motion planning and control side to the computer vision estimation, kind of like think like SLAM and 3D reconstruction tasks where you're trying to solve for a bunch of variables.
So yeah, that's really interesting. And the sort of emergence of a black box, even in the absence of gradient descent, is definitely an interesting detail. I'm a big fan of trying to get super concrete. So if I sit down as an engineer to use this system, what is the sort of thing that I might initially be writing an expression for? And I understand that an expression is basically like, it sounds like to do this, you need to have kind of mastery of like several STEM fields at least like a college level. Like I need to be really good at like classical mechanics. I need to be good with like maybe linear algebra, differential equations. I need to be obviously a competent programmer. And then I can sit down and say something like, what I want to develop a new, is this a skill? This is a lower level than a skill though still, right? You have the skills that are like, follow me around. And these would all be kind of things we're talking about here are things that become available to the skill.
Yeah, the skills are kind of using the APIs of the core navigation system. And the core navigation system is getting the APIs, translating to kind of weights of different objectives. And those objectives are going into this lower level system that's optimizing them all.
Yeah. What's a starting ticket or like a definition where you're like, all right, this is a new, kind of below the level of a skill, but this is the sort of new optimization problem that we want to solve?
I'll give an example, a simple one. So let's say that you want to control a little race car. You're at the end of the day, you have kind of a gas pedal, a brake, and a steering wheel. So those are inputs that you get. And then there's something that happens in the world. The tires of the car are going to react to what you did. And there's a relationship with the road surface. So if you're going to build a model of that, you kind of start with the simulation and the dynamics. So how do the inputs translate to outputs? And you basically need to build up a model of, okay, well, when the tires turn, it moves on the ground, and you might assume no slippage. So the radius of the tires is part of the function of that. And you make some assumptions, and you say that as the tires spin, you're moving at some speed. And if the tires are turned, it changes your direction in some way. And you have to kind of write equations for those bits. And you say, when you hit the accelerator, here's how that relates to the actual speed of the tires with some time constants. And when you turn the steering wheel 10 degrees, here's what the tires do. They might only turn 5 degrees, or they might turn 20 degrees, or it might be a nonlinear function. And so as a roboticist, you kind of design those equations to model what you have. And so to actually make this sort of system work, like let's say you then want to make a self-driving race car, you have to do a lot more on top of that. You have to solve some kind of problem on top that's doing stuff with those inputs. And often you need the derivatives of those equations to control their dynamics, like a differential equation. And to effectively do this and run it on a robot efficiently, you hit it right on the head. You have to both understand the theory of these equations, and you have to understand how to write really fast code. And you have to understand how to implement, in C++ or a low-level language, the derivatives of these things. And it's a lot of different skill sets. And so by decoupling a few pieces of it, if you can just write the equations in like a mathematical, analytical sense, without thinking about how do I take the derivatives of it, without thinking about how do I make it fast, and then make that part automatic, then it opens the door to any grad student that is, focused on the theory, but not the time to really make it productionized and free of bugs. And there's just so much of the path of robots that is that, just figuring out where you screwed up. And it's hard to maintain like a low level implementation of something that's supposed to be fast, and see the big picture of like, oh man, I wanted the equation to be this way and it would be better. And so that's kind of the relationship that I see. And of course, there's the question of, well, do you need to write those theoretical equations, or can you just learn them? And I think my perspective on that is it kind of depends a lot. Obviously, it's nuanced, but I would say if you're sure that something is true, like for example, gravity is a pretty simple example.
F equals ma.
Yeah, you don't want to learn gravity, and if there's a way to incorporate that, whether it's in the structure of a deep network or the output of a deep network gets used in a way that knows about the physics, you probably don't want to rely on learning that, because you're just going to create more room for error. And that same thing is true in a bunch of ways of, the dynamics of these tires and the steering wheel. And so if you know something exactly, it's probably best to use it. If you know something almost exactly, let's say as your tire wears out, the radius changes a little bit, and therefore your mapping of the speed of the tires to the speed of the car is not well known. So those are cases where, and a more complex example would just be like the aerodynamics of the drone. What happens when there's a gust of wind and the propeller is spinning at a certain rate, and you have the physics of those interactions? Or even if you're taking a picture with your phone camera, like what's the exact model and properties of the lenses? Those things change with temperature. You might assume you know things, but you don't exactly. In those cases, it's probably often best to have that be an initial guess for a learning-based system, like something that says, I strongly believe this is the answer, but here's the rough error bounds, and you're going to figure out that answer. And so the more you can kind of build in that kind of stuff, and then the more the dynamics are very complicated, like pixels to some decision, there's just no possible way to model that parametrically. You have to learn it. And so I think our journey has been one of just figuring out when to use just like learning end to end, when to incorporate geometric primitives into a deep network such that the job it has is simpler and more fundamentally sound, when to give initial guesses in the right ways, when to post-process the outputs and combine with a more classical kind of optimization system like with SymForce, and where to draw those boundaries. Because at the end of the day, there's a lot of value that also comes from the intermediate outputs. Like, we don't just create a 3D map of the environment so that we can avoid the obstacles. We create a 3D map of the environment so that we can then scan it, so we can show it to the user, so we can build a 3D model that gets used for inspection, so that we can click on a point on the phone and know exactly how far away it is to then let the operator make a decision. And so there's just a lot of trade-offs that come between those, and supporting why sort of end-to-end reasoning and design by like a dedicated team that controls the whole stack is really important.
You mentioned like 8 or 9 different networks that are running in this kind of concert with the human designed, the human architected systems, and just kind of ran down like a bunch of the different functions that they play. And they're all kind of in this, it's almost like they're grafted together with the kind of traditional software. Do I understand correctly then that like identifying things like tree branches is something where video comes in, there's like a neural network component that essentially identifies where things are, and then those things, potentially reported as like relative coordinates to the drone itself or whatever, get fed into the highly optimized code that came out of SymForce as like a constraint. That had been sort of, all that optimized code had in turn been prepared upstream by somebody that's like, okay, now I'm going to sit down and think about how we want to deal with, a certain class of like objects that are, a certain distance away from us or whatever. I don't know how, we could divide those up in a million ways, but somebody at one point said, okay, when there's a twig that's like above us and it, appears to be small or whatever, we're going to, handle it in this way. And now that's kind of translating to all this low level code that's receiving those inputs out of a neural net. But then on the other hand of that, you also have like, well, the outputs of the code itself may be just a guess, and then there's like another neural net to kind of correct.
It's a good example. So I think the minimum viable piece, the part that is just incomprehensibly, harder, more difficult to do without deep learning, is the part that says these pixels of this image are a very difficult to see thin branch. Like, that is just that is the state of the art. And you can take that and you can kind of figure out the rest then of, like, let's say you want to build a 3D understanding of that. You need to know exactly where your camera image was taken. You need to know exactly the properties of your lenses to understand how a 2D pixel coordinate maps to a ray in 3D, and then to what is the depth we're using by figuring out across multiple frames in motion of the drone, or across further kind of geometric reasoning. So the interactions between those systems can be designed in multiple ways, and you can go more end to end. So you can have a deep network that is not only reasoning about a single image, but it's reasoning about a video of images. Or you can have a deep network that's directly thinking about 3D and outputting a 3D representation. Or you can have two separate ones, kind of one that's focused on the pixels and one that's focused on then constructing kind of 3D understanding from those representations. And there's like real trade-offs between these approaches in terms of how much data you need that's kind of all synchronized together, how difficult and much of an effort it is to train, how robust you get the output, and what the edge cases are. And there's just really valid arguments for a bunch of different approaches, I would say. But the more, and I'll say the more high level you get, the more it's really beneficial to do joint reasoning and end-to-end using neural networks. I think that's kind of really clear to me.
The broad trend, right, would seem to be more designed systems are kind of broadly giving way to like more black box, more end-to-end systems. Are you starting to see that in your own work? Are you seeing like, you mentioned Elon, and one of his favorite mantras that I always think about is the best part is no part. So are you starting to see the opportunity to eliminate components and, kind of merge components into bigger, but potentially less scrutable pieces? Or is that not really something that is happening for you yet?
In some ways, I think this played out in a more direct way for us when deep learning was first emerging. And we kind of saw opportunities to get rid of a bunch of, complicated code with the inference of a deep network. That for sure, several years ago now happened for us and was successful in a bunch of ways. The desire to go all the way end to end, I think, has become, it's increasingly becoming more viable. But when you're talking about things like, these higher frequency things, the dynamics of the robot, there's kind of real trade-offs to that. And so I think there's a difference between kind of what is our biggest focus at Skydio in building right now, and what would be the case if we were to build it all over again and focus on. I think if we were to build it all over again or put all of our focus on core navigation, it probably would be more end to end in several ways. All of this was talking about kind of the navigational components of the drone, and certainly there's more opportunities to get more end to end. But I want to pivot the focus of what is actually important to be end to end for Skydio right now, because it's very much higher level and more important than, I think, the core navigation blocks of our autonomy system. And it's more about the entire use case of the robot. Like, that's what we want to be end to end. That's the ultimate vision of the company. So we want our drone to not be a robot that somebody is flying with a joystick and doesn't crash, no matter how good the doesn't crash in motion is. We want it to be a robot that's an AI partner that's accomplishing tasks completely by itself, or really helping somebody that is saving a lot of time and reducing danger and things like that. And so when you pick any one of these use cases, like, for example, inspecting a bridge, the question is really, how do we get the drone to be a trusted domain expert? How do we make it so the drone understands what bridge inspection is, what different types of bridges are, what type of damage is important? Are we looking at cracks or rust or loose bolts or some other derelict thing about this bridge, and how does it accomplish tasks? How does it communicate? And we call this thing the arc of autonomy. So as we go higher level, we want to go from a person who can flies the drone, but it's easier and safer, to the drone is basically doing something for its entire flight without help. So 3D scanning is a good example. Like, you fly and you set up the boundaries of a 3D volume, then the drone goes and explores the space and builds a real-time kind of mesh, which you can see in AR, and then you pick some high-level parameters, like I want to scan this from a distance of 3 meters, which corresponds to every pixel is 1.2 millimeters in size, which tells you how much resolution your 3D model will have. The drone says, this is going to take me 40 minutes, 2 batteries, 2,000 photos, go. And then you're just watching this thing and you're sitting there and you're really, think about how difficult that would be to capture thousands of photos and make sure you got every spot correctly with the right overlap to build a 3D model. You have to be a drone expert and a photogrammetry expert. But now you're kind of watching this thing do it, and it's just way more accessible so that a company can do this with closer to any of their employees rather than a trained expert pilot. Then we go a level further, which is really the core thing we're in the middle of now, which is the dock. And the whole idea there is that the drone is, in a box that has internet and power and can be anywhere in the world. So it could be that your energy utility has 10,000 substations and there's docks installed at every one of them. Sometimes there's people there, sometimes not. But you either give an example flight or you give some kind of procedural command. Yeah, so it already has a map of the site. And what that means is you can schedule a mission to run every hour or every day, and the drone will fly, do its thing, and basically capture photos. Those photos get uploaded to the cloud, and suddenly you have basically a system that you install that's much closer to the washing machine or the printer copier combo than it is what it is to fly a drone. And then it's just delivering data at an enterprise level. Then we have a cloud that has 3D models. It has semantic understanding. You can schedule new missions. You can plan things out. But at the end of the day, the core production workflows, you're pulling off image data via APIs and sort of like AI insights on that data and integrating with some other system. And those integrations are vast and depend on which of the kind of tens of industries we're operating in. So that whole play of having the dock be this platform that's kind of horizontal, but also building up end-to-end kind of use cases from the drone flying and being intelligent about what's in the scene to delivering the integration to where the data ends up being stored and used for construction or mining or insurance or whatever. Like that's the end-to-end that really matters to us. And that's really what we're building for across the stack. And so I'd say the focus is much less on the kind of core algorithms for obstacle avoidance and estimation and so on. We've worked really hard on those. We're the best at that. But that's not where the primary focus is.
Yeah, it makes total sense. I think this is why, this concept of like what industries will be disrupted by this, I kind of keep coming back to the strong incumbents are in phenomenal position, take advantage of the latest, developments in AI, because, anybody else who wants to come in and challenge you is going to have to redo all that stuff that you've already done. And meanwhile, you should be able to take advantage of the new things, before they can catch up with all that. That seems to be the pattern in just a ton of places. Do you guys publish your pricing? Like, is it known what a dock and a drone would cost me to, if I just wanted to buy and install?
The level of the drones, I mean, this drone here, the Skydio 2, is kind of the most affordable thing we have. And in the case where it's kind of for consumers, it's in the realm of like $1,000 to $2,000, depending on what you get. But as you move up to the enterprise drones and the docks, it is closer to thousands to tens of thousands of whatever your package is. And the more end to end it is, the more it becomes about solving a problem and the ROI on that problem for that use case. And the sort of pricing is based on the value of that, and ultimately kind of software driven, where if something happens to the drone, like whatever, that's not a big deal. You get a new drone. So the model changes the more you go towards this dock and end to end. And even projecting further forward, it's like you can imagine docks are just installed around a location, for example, on a cell tower. But that same dock can go inspect a house for insurance, or it can go respond to a fire when there's, you're crossing, getting there way much faster than the fire truck's going to get there, and you have eyes on scene. And so you could even imagine sort of the docks as a service that's more like a piece of infrastructure that can be used for multiple clients and has an API. I think that's quite a bit further out for a bunch of practical reasons, but Yeah, so it really scales with the model of like, is it a piece of hardware that you fly, or is it a really end-to-end solution?
You have the room to do the value pricing because the savings is somewhere between like dramatic and near total, right? I mean, I'm just thinking like if I run the Hoover Dam, just to take a silly example, and I've got like all this dam, surface that I want to go inspect and look for, cracks in my dam. Obviously, being a little silly about the scenario here, but the there's a lot of surface out there to cover, and if you're telling me that it costs me basically 10-ish thousand dollars to buy one of these things and have it installed and have it go, fly 20 missions a day, then, I compare that to like, what would that cost me in terms of skilled human operators? And it's like, it's going to be somewhere between probably 1 and 5%, and maybe even sub 1% of, what it would cost to have a team out there, especially if you're doing it the old school way with like ropes, then in today's world, that's pretty expensive. So it's interesting that there's so much savings that then you can kind of think about pricing in a lot of different ways and still be like a dramatic savings to the customer.
I'll give you two visceral examples. I mean, one would be, let's say you're inspecting a bridge, and a common way to do that is to use a snooper truck, where basically you stop a lane of traffic, you pull a guy over in this like multi-legged arm in a bucket, and it goes around the bottom of the bridge. And even putting aside the, basically like the safety concerns of operating this truck and what happens when you have an incident, how damaging that is to a large kind of infrastructure player like a Department of Transportation. Just straight up think about the cost of closing down a lane of traffic on an important bridge. And you ask like, what is the price of that per minute? It's astronomical. And a second example is just the cost of using helicopters for something like either a situational awareness use case, or they're frequently used for something like transmission tower inspection. And the cost of a helicopter, both from a safety and training and also from a fuel perspective, is very, very vastly different from a small electric drone.
So if I imagine not too long time in the future when you've got kind of a broad mesh of coverage and this becomes kind of an Uber style service where I could say, I'm the fire department, I'm going to, a scene, I need eyes, and even do it from an app perhaps, right? If I'm imagining like, what is the cost of this kind of go to in the limit? I think like, okay, maybe it's a $10,000 setup, and maybe that lasts a few years, whatever. And even just taking daylight hours, there's something like 5,000 daylight hours in a year. So it seems like we kind of get down to like $1 a mission. Is that kind of what you would expect this to ultimately be like? Like if I could call my, and at that point, then you have like a ton of, consumer, then you're back to being a consumer company perhaps, because you could be like, I want to get a little aerial footage of my kid's soccer game. If it's $1 for me to bring the drone over to Total Soccer and, just film me and my kids goofing around at their, little peewee soccer practice, that's $1 well spent. I mean, does it actually get that cheap, you think?
Hey, I can't wait for the day where we get there. And I mean, it seems inevitable at some point, but there's a tremendous, like just a long path of both technical and product and kind of societal stuff to get to that point. But yeah, I mean, I don't see why it has to be in maturity. It's different than, renting a scooter to accomplish some task, or logging into some online service and doing something. So I think if we build what we're trying to build, then I think there will be a whole bunch of industry use case specific kind of apps built on top, and companies that do things with these drones and docks and missions to be a more end-to-end piece. And we're only going to be able to build like the most important couple, right? We have to focus, but we want to build that ecosystem where you can do all these different use cases. And so yeah, totally. I mean, if there's an area that has coverage with docks and you request a mission and it accomplishes some task for you, again, I think that should, that task should be priced accordingly to the kind of value that it's providing. And if you want a sweet selfie with your family, like, yeah, I don't think that should be, I don't think it should be expensive at all.
So is this also the moment, as you think about these kind of higher level, more embodied systems, more user friendly, I wonder if this is the moment where you start to deviate from that kind of vertical integration play, because I'm seeing all these things, right? And I kind of brand myself an AI scout these days. So I try to, it's impossible to keep up with everything that's going on, but I try. And you certainly see some things where I'm like, maybe you guys want to present a sort of reasonably high level API, but do you also want to be like responsible for the language model, that kind of plays the role between, it sounds like you're going more toward platform and maybe not. Also, like for data that's coming out, right? If you're going and getting those 2,000 images, I understand that you're basically to date have like owned the software as well for turning that into a 3D model. But certainly we're seeing like a flourishing of NERF type, technologies where I imagine customers increasingly may say, I want to process this in any number of ways, that are not necessarily exclusively through your software. So how are you thinking about kind of vertical integration versus platform? And are those things actually ready for the quality that you need yet, or are they still kind of not quite there?
Yeah, I mean, this is a debate we have every single week and just continually kind of discuss and evolve. But essentially, both is the answer. Partly because we have trouble saying no to things, and partly because it really makes a lot of sense. So I think the dynamics in play, like you gave the example of language models. I mean, as a natural glue of connecting together different systems and APIs, they're immensely valuable. And that's something that we will absolutely use ourselves and also allow others to use by having the right APIs. Same with kind of 3D reconstruction, visual processing. Like computer vision is our core competency. Like we have one of the strongest kind of vision and robotics teams around, and therefore it's a very natural fit for us to do 3D reconstruction. We also have more information. We have the surround cameras. We have a lot of priors on our data. We're very good at building better models with our data. But that's not to say we shouldn't let people use many, many other options that are optimized for various use cases. So we want to do the things that we're either really uniquely positioned for or can accomplish through vertical integration. At the same time, because these drones are still like, we have a lot of users in a lot of different industries, but especially with this kind of idea of a dock market, like that market we think should be much, much bigger than the market of manually flown drones. And there is literally no scaled dock deployment on the planet today. We're at a fraction of a percent of what this industry and emerging economy is going to look like. It just does not exist. And for that to cross the chasm into truly widespread use, that idea of the 10,000 substations or whatever, is that takes a really long time. And for that, like that is kind of just the big picture. Like we have to build some killer apps that demonstrate that and get it all the way there. It's for something like this, it's just brutally difficult to rely on an ecosystem play to get there. And so I think we have to go both vertical and horizontal. And in maturity, the horizontal becomes more and more important. But to get there and get to that level of like actually creating the industry, I think we have to go vertical for some of the most important areas.
Yeah, that very much echoes like the sort of platform plus killer app that even Sam Altman has been talking about lately with, why do they build ChatGPT? It's like we want to have at least one, hook into people's daily lives, so we're kind of the first and best customer for the underlying API layer. And it sounds like that pretty similar notion there. You want to provide at least some kind of core high level services and feel like that's necessary to get to the kind of the scale and value that would really support a third party ecosystem.
Yeah. The robots, the flight, the aerospace, it's all so complex that to get to the point where really traditional industries are using this thing reliably at scale, like we kind of have to bend reality to make that happen. And I think it's really hard to do that without intense vertical integration to start. As it gets more mature, then it's way more viable.
Anything else on just kind of the pure technical side that you want to cover that we haven't?
I think robotics is an incredible use case that's getting distilled from where vision and language models will kind of evolve and create value. I think of the options of those, drones are a really incredible. Like you've got manipulator arms, you've got cars, you've got maybe larger aircrafts, you've got drones, you've got robot dogs. And the great thing about drones in that space is that they can fly very close to things and indoors. They can fly very far away. They capture image data and are just very rich to accomplish tasks with. And I guess the downside is they don't interact with the environment. So the manipulation piece is more missing, although I think there's good opportunities for that if we were to focus on it. But the other nice thing about the drones is like, if it crashes in our testing, it's not, nobody's going to die. And it's not nearly as big of a deal as if you're working on a self-driving car. The iteration speed is real and there's real customers. You're not waiting to get to some level of usability to be able to sell it at all. They're already useful in a bunch of different industries. So that combination of like having this fleet of robots that is state of the art and we can develop on, but also is being used already in a bunch of different industries is a really great spot for us to be in. And I think that's a really great canvas to then apply the latest generation of foundational models and development in AI to accomplish higher level tasks. And so I think I'm just super excited about that. And it's going to trickle down to all parts of robotics. But I think our little drones are a wonderful spot of that.
Is this kind of more embodied layer, how does that relate to all the work that you've done to keep things on device? Obviously, we talked about that from a couple of different angles, but I don't envision you running like a language model on the drone, but maybe maybe my imagination is too limited there.
Every core function of the drone runs on device. And the reason it does is because you could be out at some location that's remote and has no internet connection at all. No cell service, no internet. If you have internet, it might be intermittent or it might be very low bandwidth. And you just can't rely on that for something like obstacle avoidance, right? No way. And so the drone has to do everything on board. And we've just put years and years of work into making things fast and optimized for that purpose. So as it transitions to more of kind of a dock-based world, you think, okay, well, now it's internet connected, right? Maybe it has 5G on the drone, or maybe it's talking to the dock directly or talking to infrastructure kind of internet that's set up at a facility. But still, you go to most warehouses and you ask about the quality of the Wi-Fi and the coverage, like you're not going to hear good things. And so it depends again on what layer you're relying on it for. At the end of the day, it's really best if the drone can do its whole mission without needing to rely on a link directly. So there's trade-offs there, and I think there's viable approaches for the high-level stuff to basically be running on the cloud. And certainly if you have good coverage and embodied AI and issuing high-level commands, like it might work. But at the same time, like as we have new generations of drones, improved compute, more accelerators and chips, like absolutely no question we can be able to run language models and foundation models and distilled versions of them on the drone. I think a simple example, like I think the rate at which these models are being accelerated, both the language ones and stuff like Stable Diffusion, like they are running on phones. They're running on local phones at some rates, and they're going to get faster quicker. So the biggest models with the most parameters, the state of the art, are never going to be at that point. But the rate at which they get distilled down and made faster, especially if you narrow the use cases, is enormous. It's much, much, much faster than Moore's law or anything like that. And so I think we basically see, a ton of viability in running important, larger, more common sense general purpose models, both on the edge and in the cloud.
Presumably the weight of the chips is not a big deal relative to the total weight, but the power consumption might be, especially as you layer on more and more different models and more parameters and so on. I've heard that from some self-driving companies that the power consumption of the self-driving system can actually be like material, even compared to like the actual moving of the car.
To the mileage of the car?
Yeah, that it'll take down the mileage. For example, if you have I don't know about Tesla specifically, I'm not like citing any particular manufacturer, but a friend who works in the industry said kind of a dirty secret of the whole thing is that it'll take like 25% off of your range because it's a super power hungry system. Do you know, like off the top of your head, when you send out a 30-minute flight, how much of the energy is going to compute as opposed to, actually spinning the blades?
Yeah, I mean, first, the self-driving car anecdote you gave sounds utterly insane to me, given how many thousands of pounds of car you're moving. That seems pretty nuts. It's hard for me to conceive that, but yeah, for us, I'm going to take the other side of that. Basically, like if you're flying, for us, the compute package of everything is probably in the realm of maybe 10% or so, but the impact from the weight is actually much more. And that is just the truth about these small drones, is that when you're designing the drone, the efficiency and basically battery life of the drone really depends on the size of the propellers. So the bigger the propellers, the more efficient it can be, and then essentially the weight of the thing. So the most efficient way you can make a drone of a certain size is to make the propellers as big as you can, and then have as much weight be the battery and as dense of a battery as possible. So it really non-linearly scales with any other things you need to carry, which ultimately are the cameras, the chips, whatever sensors you've put in. But the biggest pieces are the payload cameras. So this is the sort of like main 3-axis gimbal, and the boards and chips you have on board. And those things, when you need to carry that payload, basically scale up the size of the propulsion you need and take just influence the design of the entire drone in a really outsized way. And so the weight of carrying these chips, and by the way, the weight of a cooling system to dissipate any thermals you need to dissipate, also have an outsized impact. And so certainly relative to cars, where who's going to notice a couple of extra pounds, we're talking about adding 5 grams has an impact on the performance of a drone like this. So in that sense, like the size of the computer in some ways is more important than the power usage.
Gotcha. So there's kind of 3 drivers there of putting the compute, or 3 consequences of putting the compute on the device. There's the extra weight of the thing itself, the extra weight of the cooling system, and then the extra energy that both of those are going to use, which is going to in turn make a bigger battery. And all of those are getting worse. That's a compounding problem, obviously. So, but it's interesting that you're basically saying the weight of the chips is a bigger deal, especially I guess the weight of the cooling in particular is a bigger deal than the extra energy that it needs, which in turn makes a bigger battery. I'm kind of surprised, but obviously your stuff. That's fascinating. I'm gonna have to go back and talk to my friend in the self-driving car game and see where all that energy is going. Dig a little deeper on that one as well.
I mean, just consider that our drone has to keep this thing in the air. A car is rolling along the ground and it already is thousands of pounds. The drone is like orders of magnitude different than that.
The self-driving car thing, I think, strikes me as a very weird kind of disconnect between what I have personally experienced just riding in a FSD Tesla not long ago, and the sort of broader narrative, which is like it's many years away. It didn't feel like it was many years away to me when I got in one. My neighbor happens to own one, and just he put into the navigation system, here's where we want to go, and we just rode. And the car drove the whole way, city streets, get on the highway, get off the highway. It did everything but park, oddly. What's your view on that? Do you think that we are actually a lot closer than people think? Or what would you kind of expect for consumer autonomous systems? Obviously the crown jewel goal is the self-driving car.
Yeah. So I'm pretty close to this because my best friend and actually several friends work at Tesla Autopilot. And then I'm also close friends with another self-driving founder of a company called Wave in the UK that is really focused on end-to-end approaches to self-driving. So in both those cases, I mean, I think it comes down to just like a lot of stuff is handled well, and you may go on drives that feel incredible and you just see incredible things happening. But at the end of the day, autopilot is in a mode where the humans expected to take over, right? It's a beta. It's technically, the thing. So if you had a car and you want to truly just chill and sleep in the back while it's doing its thing, what is the 1 out of every drives of it crashing would you be okay with? If it was 1 out of every 1,000 drives, would you accept that? Or if it was when on a day where the weather is really nasty and it's a combination of, hail and fog or something, or you go somewhere new, or there's some horrible construction with the wrong sign put up or something. And so just the distribution of this stuff is so far down the tail end of edge cases, where the easy case is just like, that's been solved a long time ago. And so, there's different approaches to this, from gathering data at a massive scale to like relying on foundational deep networks that can generalize and reason like a human would and adapt to approaching this problem. But I think in some ways we just see fatigue, because people have been talking about self-driving being people, including Elon, talking about how it's always a year or two away, and now it's been a decade. And I think we're getting closer. We're making progress, but and it will happen, and we are getting But it's one of these things that's just the horrible dynamics from a product side of for it to actually ship as a thing, not as a beta that you're ready to take over, but as something where you're actually trusting your baby to be asleep with you in the back. It's just like such a different bar that you need to get to. And frankly, that bar is much higher than the actual accident rate of a human, because every human is like, thinks that they're a better driver than the average. And every human would rather that they made a mistake and crashed than an AI that's driving made that mistake and crashed. And I think it's just untenable until you can prove that you're not just better than a human, but orders of magnitude better. We may already be better than a human in many cases.
I think that's really interesting. And I imagine you have a version of this that you deal with at Skydio too, where it's like, people have been doing these tasks in all sorts of ways, right? Whether it's literally climbing the cell tower with a rope versus, driving an earlier generation drone manually, or, whatever in between. Do you have a kind of hurdle that you guys try to hit or convince, demonstrate to people that you've hit? What do you think that hurdle should be? Like, to me, honestly, you asked the question, like, certainly if it was one order of magnitude safer than human driving, I'm on board with that. Like, I can't credibly think I'm more than an order of magnitude. I doubt I'm an order of magnitude better than average. That seems like a pretty bold position for me to take. Maybe, if I'm really good and I think I am, like, more careful than some of the yahoos I see around, around me, but still, order of magnitude is a lot. Do you think that is like just still societally not enough, or what do you guys see from your customers, in terms of what their elevated standard is for systems versus humans?
Yeah, I mean, for the car case, I think order of magnitude is about right in my mind as well. From the drone side of things, I think it's pretty different. Like, you're not, like, people's lives aren't at stake in the same way. In some ways, you're like obviously taking the safety of people first when you replace some dangerous activity with a drone. But we see these dynamics, I'd say, more playing out like somebody who's inspecting a structure in some other way, even with a drone today, like they're manually flying a drone with a trained pilot, like that they'll have incredible sort of procedures and safety precautions. They have a standard operating procedure that has these steps, and you don't fly near things, and you zoom in and you take photos from these angles, and here's what you do, and here's your pre-flight checklist, and all of those things. So sometimes we'll come in with a drone that we just say, look, our drone will just zip around the scene all willy-nilly. It'll build a 3D map. It'll go up to 2 feet away from these objects, and it'll take close-up pictures. And that's awesome and mind-blowing, but that's so far from being a place where this operator is like, and this massive company that's built these procedures is going to be able to adopt that. And so there's a huge gap there of how do you get the benefits and efficiency and so on, but also meet the sort of like safety and operating procedures, and just ultimately enact change in a really important, critical, slow moving for a reason organization. So I think things like that are super common. And I think that kind of relates to the human robot interaction element of all this, where anytime you have a motion of the drone that's not understandable, not predictable, it creates uncertainty, it creates worry. It's like, why is this happening? I don't understand it. How do I control it? And so there's a lot of like design of making the drone more predictable and controllable. Then there's the communication of having UI, having designs, having explanations to know what's happening and take action. So all those things together are a key part of our experience.
Very interesting. That also gets to kind of another huge trend, which is just, what is going to be the future of jobs and work and all of what happens to all the drone operators, I guess, in this case. It seems pretty clear to me that, like, even if you scan a ton more stuff than is currently scanned, that this should ultimately require less human labor hours. And in some sense, that's like the whole point, right? It's safety. There's a variety of different value drivers, but ultimately the cost savings probably is the one that's going to, keep you expanding your factories time and again. What do you guys, is that part of the discussion that you have? Is there an internal discourse at the company about this kind of, societal impact that obviously you guys are a small part of, but I find that broadly this debate is kind of characterized by denial. It seems hard for me to imagine that it's characterized by denial at Skydio, but I wonder, what that leaves you with.
The dynamics are pretty different from what I would say is kind of going to happen with large language models and near kind of AGI adjacent kind of software, where a lot of white collar work across many industries at the same time will be kind of like competitively driven down in money making potential. I think that's like a very tough societal problem. I think in the space of what we operate in, it tends to be more dangerous jobs and on kind of, yeah, not fun ones. It's very hot, it's very cold, it's very remote, it's very laborious, it's dangerous. And so I think that kind of work combined with this idea that especially this dock market is a fraction of a percent of where it can be, I think leads to a place where people that are doing these jobs now, for example, climbing the towers or in helicopters, like it's kind of better for everybody if that's not happening. And I think in most cases, the people that have the expertise in these areas can become the people that have the management of a larger number of drones that are doing the work and the domain understanding of how to design those missions, how to operationalize them, how to run this program as if they had a team of the people that are now the blue collar workers and they become the kind of manager. And so I definitely think there will be an impact in a bunch of ways. And like all areas, like people need to adapt. If they don't adapt, they're going to be in trouble. I think in our case, there's way more credibility to say like these are trickier jobs, and the people involved have the right skills to bring the change of operationalizing all of this to turn it into a place where we do have way safer, way more frequent inspections, and we solve these problems. I mean, just think about something like warehouse workers. Like there is such a shortage of them right now. It's a gigantic problem, and not even just in the U.S. Yeah, so I think it's definitely something we think about. It's definitely something where people need to adapt. It's something that we're trying to be thoughtful about. I think there's a lot of reason to be, in some ways, more optimistic there than the job of kind of a middle, tier software developer or something like that.
Yeah, it's coming for a lot of different things all at the same time. And I broadly am with you on the idea that, like, I would even broaden it out on some level to, like, for jobs that people don't want to do unless they're paid to do, then if we could get us, an AI to do those jobs, like, that's great. That does obviously leave us with kind of a big societal restructuring question of how do those people still get to eat if they aren't doing the jobs that they are only doing now because it allows them to eat. So there's like a new, arrangement perhaps that needs to be developed.
Universal basic income.
Yeah. I mean, are you, it sounds like you're ready to endorse that.
I'm ready. Yeah. Yang gang. But I don't think we as a society are nearly in a place to execute on that, at least in the US. Like the world is barely hanging on from not just having it all be entirely authoritarian dictators. So there is an amazing society from the gains in productivity we're going to have if we play our cards right. But we're pretty far from being in a position to play our cards right. And I'm afraid about that big time.
Yeah, I've started saying it's the smartest of times, it's the stupidest of times. It seems like somehow they're coexisting in a really weird way. But I'm broadly with you. I think the UBI vision makes a lot of sense, and it would smooth the transition that seems like it is coming at us in a at a pace that is not necessarily shaping up to make things super smooth. So anything we could do to kind of ease, transition for all sorts of people seems like a great idea to me.
If it happens, it's always happened to different industries, over and over and over in history, and society adapts. If it happens in all of them at the same time, that's much more dangerous the quicker it happens, and I think that's part of the risk. The possibility of that leading to just an incredible amount of wealth inequality is very high if not managed carefully. But the potential for enormous societal wins are there too.
Well, here's hoping we can go from here to there. You mentioned also authoritarian dictators, which is the natural bridge to my last topic that I wanted to ask you about, which is the use of drones in the military, and specifically, it's been widely reported as a key dynamic in what's going on in Ukraine. I guess for starters, like, you guys do sell drones to defense. From what I've seen, they're purely kind of eyes in the sky situational awareness products. Are you able to, and are you selling them like directly to the Ukrainian forces, or what does that kind of supply chain look like between the company and the customer in that case?
Yeah, again, caveat that I'm an engineer, but I do have a decent amount of visibility. So yes, Skydio, absolutely, we sell to both kind of like local, police and fire and things like that, and also all branches of U.S. government and international governments as well. So we definitely have. I don't know that if we work, how directly it is with Ukraine versus kind of partners that act as players there, but absolutely, Skydio as a company, like we have a lot of expertise. We have a lot of veterans and Navy SEALs and experienced people in that area, and a lot of understanding of the product needs. So from a product perspective, we are focused on camera drones and sensors. Like, we have a set of published kind of principles, and one of them is that we will not weaponize our drones. And for a bunch of reasons, like we're focused on the camera and the reconnaissance as the core focus of our products there. And so we have definitely sent people to Ukraine from Skydio to train and provide effective use of these things. And there's a bunch of different things happening. Like, there's absolutely people strapping things to cheap drones and using them in warfare. Then there's larger devices of different classes, and we are like a slice of that for reconnaissance. And we have, I guess, certain advantages in kind of being, well, the largest incumbent drone company is a Chinese company called DJI, and that's kind of, they're amazing at making hardware and low cost and something. And so we're the largest US drone maker, but they're the largest world drone maker. And so there's some geopolitical dynamics there that go on with the company and also in Ukraine. The other thing is just our drones with the autonomy tend to operate better without GPS. And so that's kind of a key thing where you can just assume GPS doesn't work in Ukraine, whether it's jammed or faked or whatever. It's just not really good to rely on. And so that's the sort of ecosystem in which things happen. And I think people are realizing that, again, small drones are so much cheaper than human lives or larger traditional defense equipment that's orders of magnitude more expensive, that it plays a role.
The weight of the device, just from the couple times you've held it up, it looks like it's like 2 pounds at most.
Yeah, this one's just around 2 pounds. Our current gen kind of enterprise drones a little bit more, but not a ton more.
Obviously, as you mentioned, a ton of different drones from a ton of different places in the field. But does that have the power to like attach something that you could then carry and deliver somewhere? It seems like it wouldn't be able to carry much at all before it would just be too weighed down to carry out the mission.
Yeah, a tiny bit, but definitely our drones are not optimized for that, especially these ones. And even if you have the autonomy system enabled, and the cameras see something they don't expect. So so I think you can make it work, but it's just like, you're better off buying a toy drone if you're trying to carry something. At some point, we may focus on delivery, and maybe that has a wing drone, and there's some amazing companies working on that. Like Zipline is a great American drone company focused on that, but that's not our focus right now. And there's so much surface area with just cameras that, like, we're gonna roll with that for quite a while, I think.
So what have you learned from watching this conflict unfold? from, the particular angle of being somebody who makes drones?
I don't know how qualified I feel for that. I mean, I think war sucks is a one that kind of becomes real, and I think a lot of people just didn't expect something like that to happen in the modern era. Like it felt like Europe could not break out into war. Like it seemed inconceivable to most people. Yeah, I think mostly just how real it is, and the fact that we've had a bunch of people from Skydio go to Ukraine, to the Polish border, and work on training, and it just makes it all more real. So I haven't done that. I'm not like that's not where my focus is, but um, yeah, it's wild.
Is it feeding back into the product development cycle at all? Like I read one report that there's like 10,000 drones that Ukraine is losing on a monthly basis. And I've obviously probably again, wide variety of makers and sources of those, but electronic warfare was kind of cited as like the way that they're being knocked out of the sky. I really don't know a lot about that, but I imagine that must be something that you're kind of thinking, geez, next generation, especially in defense, like what kind of defenses, if any, could we, try to build on? Anything that you could share about the future there?
I mean, I think the most common thing there is basically like jamming or spoofing of GPS. Since most drones, is traveling long distances, you're relying on GPS satellites, and that's just like kind of a no go. So there's definitely a ton of product feedback and features that come back in around like what is just getting in that mindset. Like the average robotics engineer is not in that mindset of what is a useful product feature in that scenario. So definitely being able to do missions with less reliance on external signals is like the number one thing. But there's a bunch of different product features, and that gets into the nuances and details of everything. But we, as like a dual use kind of commercial enterprise government company, we just get from all the different industries, we get a lot of different product requests and features, and it's hard, but we're trying to balance like those pipelines and how to have a unified product vision that covers as much as we can and makes that's the biggest execution risk of the company, is like having a lot of good use cases that we do, but no like amazing ones. And I think it's the challenge of that horizontal and vertical balance, and having the right features that we build in the right order. That in some ways you want to spread the pain out, so you're developing all the different use cases, but in some ways you really want to prioritize and say we're going to make this amazing and win at this, and move on. And so I think certainly from a Ukraine type scenario, it's a use case that's really important, and something that we want to like understand the product, and do the best that we can, while also realizing that we're not a defense contractor, and that's not that can't be the primary focus of what we're doing either.
Obviously, there's been conflict in your own home part of the world too, between Armenia and neighboring Azerbaijan, and you were just there as well. So, I don't know if there's any intersection between your visit and kind of drones and all of the. I'm sure they're being used in that theater as well, right?
Absolutely, yeah. There's I was at the Azeri border, and you could see like flags of both types lined along both sides, and even there was a drone strike the day after. Um, we were in that area, and so there's a lot of kind of Turkish drones going to Azerbaijan being used in this conflict, and there's a lot of ways to look at it. I mean, it's a really sad thing. I mean, obviously the conflict in Armenia for us, but also the use of drones in those ways, and I think for a bunch of reasons, basically, I'm against, especially weaponized autonomous systems, and that's really really common across robotics researchers and AI people, and I'm squarely in that line, and it's hard to not get wrapped up in kind of an arms race of like, well, this entity is doing it, we have to do it too, and there's a lot of arguments for that, but it's just a really tough thing to navigate. But like any sort of powerful new technology, it gets used in a lot of really good ways, and it gets used in some really bad ways, and it's a tough thing to navigate.
Yeah, I think that's one of the biggest themes of this show. So that's a great, sobering but very real note, I think, for us to end on. Hayk Martiros, Skydio, thank you very much for being part of the cognitive revolution.
It's been a blast, Nathan. Thanks a lot.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.